Good morning. My name is Isha Mure and today I am here to present on the topic analysis modeling for function oriented. So these are some topics which we are going to discuss in today's presentation. Let's first understand what is analysis modeling. Analysis model is a technical representation of the system. It acts as a link between the system description and the design model. In analysis modeling, information, behavior, and the functions of the system are defined and then translated into the architecture, component, and interface level design in the design modeling. Basically, analysis modeling provides a common framework for the stakeholders to discuss and validate the system's requirements, which leads to an improved system quality and reduced risk, also enhanced collaboration among project team members. Here is a diagram to understand analysis modeling in a proper way, which includes data object description, which is shown by or represented by ER diagram, and the state transition diagram represents control specification, and the process specification is represented by data flow diagram. So this is the structure of analysis model. There are various objectives of analysis modeling, which are as follows. Firstly, analysis model must establish a way of creating software design. Also, its main objectives are elicitate and identify system requirements, means what are the requirements of the system, and to analyze and understand the relationship and dependencies among various requirements. After identifying the requirements, it should also find the dependency or relationship that the requirements are having. The document requirements should be clear and unambiguous. There should not be any confusion in the document process, or any documentary should not be incomplete. And it should validate the requirements for correctness, consistency, and feasibility. That means the requirements should be correct and consistent. Also, analysis modeling should facilitate effective communication and collaboration among stakeholders. Means there should be a communicative there should not be any communication gap or proper improper communication between the stakeholders so that requirements are taken properly and correctly. Also, it should define the scope of the system and identify the potential risk associated with the requirements. So these were the objectives of analysis modeling. So there are two approaches for analysis modeling, which are function-oriented analysis and object-oriented analysis. So let's first understand what is function-oriented analysis. Function-oriented analysis is an approach that is used in software engineering to analyze and to understand what functions or tasks a system need to perform, and it mainly focuses on identifying the primary functions or the processes of a system and how they interact with each other. And if we try to understand it in simpler words, it basically helps to break down a complex system into smaller and manageable functions or tasks, so that this analysis involves identifying the inputs, outputs, and the processes involved in each function. So there is an easy understanding in the dependencies and relationships between these different functions. Overall, function-oriented analysis provides a systematic approach to analyze and to describe the functions or tasks that the software system performs, and enabling effective design and development process. Let's also understand object-oriented analysis in short. Object-oriented analysis is an approach that is used in software engineering to analyze and to understand a system structure based on the objects it has, and it mainly focuses on identifying the objects in a system, their attributes, and their actions. Object-oriented analysis helps in modeling and designing software systems by breaking down them into reusable and modular components, which is called as objects. Object-oriented analysis involves techniques like use cases diagram, class diagrams, and sequence diagrams to represent the system's requirements, the behavior of the system, and also the relationships between the object. And basically, the main objective of object-oriented analysis is to identify the objects, the classes, and their interactions that form the foundation of the system's design and implementation. Here are some differences between object-oriented analysis and function-oriented analysis. Function-oriented analysis begins by considering the use case diagrams and the scenarios, and in object-oriented analysis, we first identify the objects and the classes. And object-oriented analysis is carried out by UML diagrams, while the function-oriented analysis is represented by diagrams like data flow diagram. So these were some basic difference between function-oriented and object-oriented analysis. Now here is the list of components of analysis modeling. First is the functions, which are the core elements of any function-oriented analysis modeling, which represent a specific task or action that a system needs to perform. Second is the function hierarchy. A function hierarchy represents the hierarchical structure of functions that are present within the system. It establishes relationship between the higher level functions and the corresponding subfunctions. Next comes the data flow. It is also an important component of analysis modeling, and it represents the movement of data between the functions. And in simpler words, it illustrates the flow of information from input of one function to the output of another function. Next element is data stores, which represents the location stores where the data is stored and retrieved by the functions. Next is control flow, which represents the sequence and flow of functions, or basically depicts the order in which functions are executed and any conditional or looping constructs that controls the flow. Another one is interface, which interfaces are defined as the interactions or communication points between the functions or the system and the external entities, and they are used to represent the inputs and outputs that are exchanged between the system or the function. And the last one is process specifications, which helps in the description of individual functions, including their inputs, their outputs, algorithms, and any constraints or any requirement associated with them. Next, we will discuss about data flow diagram. So, a data flow diagram is a graphical representation that shows how the data moves through a system or through a process. It illustrates the flow of information from one component to another, which highlights the inputs, the outputs, and the transformations that occur along the way. Uh, Basically, data flow diagram depicts how the data is processed or manipulated within a system. Data flow diagrams are helpful in visualizing and understanding the flow of data within a system, identifying the sources and the destination of data. Also, data flow diagram helps in improving the communication among project stakeholders and ensuring that the data is properly managed and utilized. Also, it helps in facilitating system analysis, design, and communication. It is a visual representation that helps us to understand how the data is processed and how the data flows through a system or a process. So here is a data flow diagram which will help us to understand how the data flows in a data flow diagram, and how a data flow diagram helps us in understanding in a better way also for the stakeholders to understand the flow of data through the system and throughout the process. These are the components of data flow diagram, which are external entity, process, data storage, and data flow, which are represented by the given diagrams respectively. Here is the explanation for components of data flow diagram. Firstly, the entities. Entities are nothing but the source and the destination of the data. That means these are the place from where the data is transferred and to where it is transferred, and these are represented by a rectangle with their corresponding names. Second is the process. A process is a task or a function that is to be performed on the data, and it is represented by a circle. Next one is data storage. Data storage are basically the storage locations where the data is stored. It includes the database of the system, and it is represented by a circle with both smaller sides missing, or in other words within two parallel lines. A rectangle is represented is used to represent data storage. The last one is the data flow. Data flow represents the movement of the data in the system or between the processes. It is represented by the help of an arrow. Here is an example of data flow diagram for representing a library management system. Here, a student is used, which is an external entity whose name is student, and these arrows are representing the flow of data within the system or between the processes. And this bookshelf, list of authors, list of titles, and list of borrowed books are representing the data storage where the data is stored. And these get book, find book book position, update list of books are these are representing the processes or the functions that a system has to perform. So this was an example of data flow diagram which is representing a library management system. ER diagram. An entity relation diagram is also a graphical or visual representation which is used to design and to understand the structure and relationships of the data in a database. It depicts the entities which are the objects or the concepts and the relations between them. If we talk in simpler words, ER diagram is like a blueprint that shows how different pieces of information are connected to each other, and it consists of three main components that are entities, relationships, and attributes, which we'll be discussing further in the next slides. And ER diagram is mainly helpful in designing and visualizing the structure of a database and identifying the relationships between these entities or the objects and ensuring data integrity and consistency. These ER diagrams helps to provide a clear and organized way to understand how different pieces of data are connected and how these pieces interact within a system. Now comes the components of ER diagram. Firstly, the entities. Entities represent the objects or the concept in the real world that are storing the information in the database. Second is the attributes, which describes the characteristics of the entities. Then it means the entities which are present, their characteristics are represented by the attributes, such as student's name, student ID, and date of birth are the attributes if the entities are students or the courses and the professors. Third one is the relationship. Relationship illustrates the association between the entities. They define how entities are connected to each other. For example, a student can be enrolled in multiple courses. So these are the relationships. And the fourth one is the cardinality. And cardinality is used to specify the number of instances of one entity that can be associated with another entity through a relationship. And cardinality is used to help in determining the minimum and the maximum number of relationships between the entities. Here is an example of an entity relationship diagram for library management system. So here, as we can see, these diamond shapes are representing the relationships between the entities, and these rectangle shapes are representing the entities or the objects here, while these elliptical shapes or oval shapes are representing the attributes which are the properties of the entities. So here in this library management example, published by and browsed by, these are the relationship, and the date, due date, return date, issue, or the entities related or the attributes related to books are price, available, title, book ID, author. These are the relationship. These are the attributes which are related to the entity book, and these are in relationship with the publisher, which is another entity whose attributes are public ID, address, name. The another entity is member, whose attributes are expiry date, name, address, member type, member date, member ID, and etc. So this was the diagram and the explanation of ER diagram for which was representing a library management system. These are some advantages of function-oriented analysis. The first one is the focus on functionality. Functional-oriented analysis places a strong emphasis on understanding the functions or the tasks that a system needs to perform, so there is better performance due to focus on the task. And second one is modularity and decomposition. Due to distribution or decomposition of system in smaller functions, it is better and easy to understand the functions. The third one is the clear data flow representation. As data flow diagram is very clear, so it very clearly explains how the data flows between the process and what are the relationships between different entities and how the data is flowing through the system. Improved maintainability means the maintainability of the software and the system is good, and the focus on data dependency means how the data is depending and what are the relationships between the entities and the functions are more focused, and also the improved communication and collaboration. There is an improved collaboration and the communication in function oriented analysis. So these were also some advantages of function oriented analysis. There are also some disadvantages of function-oriented analysis, which are limited representation of real-world objects, means there are less representation of real-world objects in this function-oriented analysis. And next is the lack of reusability. Here, the emphasis on reusability of components is comparatively less as compared to function-oriented. And the maintenance challenge is also a tough task here in the function-oriented analysis. Limited support for dynamic behavior, lack of user-centric perspective, and increased complexity in large systems. That means the complexity due to large system is increased. These are also some of the disadvantages of function-oriented analysis. So that was all about function-oriented analysis. Thank you.